one there and one there from this, yeah? Is everybody happy with that?
Mm-hmm.
Yeah.
Okay. Right, if we then look at our chlorine, we've got Cl there. And for the same reason, we can't have MgCl, for the same reason we already talked about. That was definitely right. We've got to have a 2 there. Okay. You happy with me about that? Remember
Why?
Because
Yeah, I'm a bit confused. Why we
2 plus, this is Mg2 plus, and this is Cl1 minus, remember.
why do we have
Oh,
to put
right.
a chloride there though?
Is it
That's
is it because chlorine only take 1, but it needs to take 2?
okay.
Like 1 electron?
That's our salt. Magnesium chloride is our salt.
Okay.
Okay. And that is our water. So I said an acid and a base. So acid plus base. This is harder to use than I thought. Never mind. Acid and a base make salt and water, yeah? That's what we said. And magnesium chloride is just another salt. It's not the salt that you chuck on your dinner, although you can. But so magnesium chloride is just another salt. So on this side, we've got 2 chlorines because this is in group 2, so the charge on this is 2 plus. The charge on a chloride ion is 1 minus, so we need 2 of them, exactly the same as we said before we got muddled. So over here, we've got 2 of those, yeah? We've got, over this side, we've got 2 oxygens, yeah? Everybody happy with that? Because those in brackets. And over this side, we've only got 1. Yep. So now you can see that this is a fairly simple fix.
Yeah.
Okay, how am I going to fix it?
2HCl.
Okay, right. If I go 2HCl, oops, 2HCl, so then I've got another Cl there, and I've got another H there. Do you agree?
Yeah.
Mm-hmm.
Okay, so now what am I going to do on the other side?
2H2O.
H2O. Oops, 2H2O. So then I've got another 2 of those and another one of those. So now everything's happened. Yeah?
Yeah.
I did promise you though that you would not have balance equations, and I'm true to my word. There's only one question I think in the online quiz that has anything to do with balancing equations.
Okay.
All right, but that's how you do it. Sorry, we got that muddled before. I should have realised that was MgOH2 in the first place if I had, because that's got a charge of -1 on the OH group, and that was the one of the ones I said for you to memorise.
Mm-hmm.
Because that will come up again. Okay. Are we happy about the blood buffering?
No, I don't understand it.
What am I up to?
I'm wondering if I can copy and paste that onto here. Get rid of that. Clear.
Yeah, the blood buffering equations, is that kind of the same process where you need to have equal things on each side as well?
Yep, always. All of the equations you have to have equal on each side. So I'm sorry that I can't do the proper little things and the big things. I expected that would be how it was, but never mind. Unless that text, no, don't worry. Okay. This is the bicarbonate ion that I said to you to memorize from the common ions table.
Mhm.
This is this is the carbonic acid. Now you have to, if you haven't watched my video about this, you have to, because I go through this, and you do need to watch it. I'll see if I've got a bike on it. A bike. I've still got one. Okay. Got two, in fact.
So the thing that I don't understand about it is if like the bicarbonate, like say, loses its hydrogen, then it will become the other thing.
Yeah. So here's my bicarbonate ion. You can see I've got 2 hydrogens, 1 carbon, and 3 oxygens, which is exactly what it says, and that's what it looks like in Molly Mod land. Okay, so that's carbonic acid.
Mm-hmm.
That's bicarbonate. And if you look, 1 hydrogen, I've still got my 3 oxygens, my 1 carbon, and here's my electron that's left behind. And my proton is in my hand.
Yeah, but so if you just had one of these, wouldn't they automatically be a buffer anyway? Because if it separates, then it becomes the other one.
Yeah, yeah. So this is.
So they can't be by themselves.
No, the equation. All the equation is telling you is that this is going backwards and forth. So that will turn back on. I've got another one. Here's one I made earlier. I've got another one. Okay, and the one. Oh, goodness me. Okay, so that one's come off there. It could easily going back on a different one. Doesn't matter. I could have, if I had this situation where I've got 2, remember upside down is not a thing. It doesn't matter what way up it is because it's a molecule. It doesn't know which way is up. Okay, so here I've got my 2 bicarbonate ions, and I've got 2 protons. You see them?
Yeah. Yep.
2 protons, right? So what's my pH? Is it high or low?
Lower.
It's
low.
lower. It's lower. More acidic, lower. If I reform one of those and reformed carbonic acid, has my pH gone up or down? I've only got one of these now.
It's gone up. But that doesn't
It's
make
gone up.
sense, because if carbonic acid's the acid, then that's like, wait, so that seems like the full carbonic acid seems less acid than the bicarbonate does.
Right. Okay, so this is where
swapped.
This is where the whole kind of head mess starts. It's not the acid that makes the pH higher or lower. It's the proton that makes the pH higher or lower. So in order to fix the problem of something being too acidic, like your blood being too acidic, acidosis, to fix that problem, you reform carbonic acid. So you're actually making more carbonic acid in order to make the blood less acidic.
So that's when you say you want to mop up the protons.
That's right. You want to mop up the protons by reforming the carbonic acid. And that's where it's hard to get your head around. So it's not the acid that's the problem. And that's why when people start banging on about lactic acid making their muscles hurt. No, lactic acid does not make your muscles hurt. Lactate, which is the iron, and the protons make your muscles hurt, not the lactic acid. The lactic acid is fine, not causing a problem at all.
Okay.
So is the like for these two, say the acid itself is more like alkali, but because it has potential to let go of one, it has potential to make the solution or whatever more acid. Is that right?
That's a very good word. Potential. Yeah, that has the potential to cause the pH to drop. Now, this is a weak acid. Carbonic acid is a weak acid. So it hangs on to most of its protons. It doesn't lose them very easily. But a strong acid like hydrochloric acid in your stomach, almost all of it is in the protonated form. So almost all of it, here I've got some, I only just put these away because they were blowing everywhere. But here I've got some, this was hydrochloric acid. I don't know if I've got any left because they're all ionized. Okay, you definitely have to watch my video. Okay, so these were hydrochloric acid, but because hydrochloric acid is a strong acid, and a strong acid, almost all of it is in this form. So almost all of it is like this, which means that I have got, and I put them down, I have got a whole load of, hang on, it's really hard to get in the screen. I've got a whole load of protons because it falls apart as soon as you put it in water. And you can predict that because you know that chlorine doesn't share electrons nicely with anything, especially hydrogen. And this is what I was saying the other day. Mathematically, this would be ionic. It's not, it's just extremely polar. And as soon as you put that into water, it all ionizes.
Right. So when it's not in water, it's covalent?
You don't get it not in water.
Oh.
It comes the most concentrated it comes. Remember, concentration is not the same as strong. The most concentrated it comes is about 68%. You can't get it. It doesn't exist as a dried sort of thing because it's two gases if you think about it.
Can it just be the two gases by themselves?
Can they be
like in that form?
Well, both of them can only be H2 or Cl2. But you can make and in fact I actually hurt my eyes quite severely by negating hydrochloric gas, or hydrochloric vapor, I suppose you call it, like you call it water vapor. When water boils and it turns into a gas, it doesn't really turn into a gas, it turns into vapor, water vapor. And that's exactly what this does. And it does horrible things to your eyes. I was in agony for weeks and I had to wear dark glasses for months. So don't ever get that stuff in your eyes. Okay, so this is a weak acid, the carbonic acid in your blood. So the acid in your stomach is a strong acid. Ionizes completely straight away. This stuff in your blood is a weak acid, so most of it is in the form of the acid. And when you think about it, your blood, the pH of your blood is between what? This is an exam question.
3.5 and 7.45.
That's right. I can guarantee that's an exam question.
Yeah.
Okay. So that's alkaline slightly, isn't it? That's slightly alkaline. So you've got a whole load of carbonic acid in your blood, and yet your blood is slightly alkaline. Because, exactly as you said, it's like this. It's almost all like this. Hardly any of it does that. And when it does that, it is causing the pH to go down because you've got lots more of these than you should have. And the way to fix that problem, which is an exam question, is to mop it up and reform the acid.